once. Okay. Before I proceed with where I left off yesterday, now is it better now?
Yeah.
I believe my cell phone was the better of the piece yesterday, so it's been put away somewhere. Before I proceed from where I left off yesterday, I was reminded of something that I might have mentioned about this extended sympathy ordering. So somebody who asked me this question was failed to turn up. Okay, it was mainly for our benefit, but nevertheless, if you recall, I defined the extended reference as an ordering defined over this space, the cross product of X, which is the set of social states, and N, which is the set of individuals. So that if you take the cross product, then typically you will have elements like this. So that in general, the objective is to have a ranking over pairs of alternatives such as xj and yk, which means ranking the phenomenon of being person j in state x vis-a-vis the phenomenon of being person k in state y. Now, all of this is very formally stated, but a much easier way of understanding it is to go back to what actually inspired Kenneth Arrow to actually discover these extended preference orderings to employ them in his work. Apparently, when he was visiting England, he once saw a 17th century tombstone on which the inscription provided him with the motivation for coming up with this extended ordering R tilde on the space given by the cross product of X and N. And this inscription read as follows: "Here lies Martin Engelbrod, have mercy on my soul, Lord God, as I would if I were thou, Lord God, and thou wert Martin Engelbrod." Okay. So this he saw as an example of an imaginative exercise on the part of the individual to put himself in the shoes of the other person and also to invite the party of the other part to put himself in the capital H in his place. And that is what led to the formalization of the notion of extended sympathy. Okay, that was just by the way. But where we had left off yesterday was in terms of various compensation criteria, which were a product of an attempt to answer the question of how welfare economics, with its emphasis on purely ordinal, interpersonally non-comparable utilities, would be capable of ranking Pareto non-comparable social states. And we discovered that the procedures which were prescribed both by people like Calder, in terms of the Calder compensation test, and its subsequent strengthening by Swiatkowski in terms of the Swiatkowski compensation test, were neither particularly ethically appealing nor, and this was more fatal, were they logically coherent. Okay. So, as I said, the whole problem arises from the way in which welfare economics stipulates the kinds of information which it regards as being scientific or admissible. So if you rule out cardinality, if you rule out interpersonal comparability, even within the restricted domain of utility, forget about non-utility information, I'll come to that later, then it's inevitable that you're going to run into certain kinds of problems. And the definitive version of the problem which attended this way of viewing economics was ultimately reflected in Kenneth Arrow's general possibility theorem, which was first proved in 1953, I think, and subsequently in 1963. By the way, I must tell you, I had occasion to ask Arrow once whether this was a true story or an apocryphal one, that it took him only three weeks as a doctoral student when he was working for his PhD to actually crack the problem. And he said the story is apocryphal. It didn't take me 3 weeks, it took me 2 days. And apparently the first day that he worked on it, he was getting a problem with what are called triples, namely with sets of alternatives consisting of 3 alternatives each. And he thought to himself, surely it should be possible to extend this to any finite set of alternatives. But he was very tired at the end of the day, and he went to sleep, and he had a disordered sleep. He didn't sleep very well because somewhere at the back of his mind his problem was still operational. But then he got up next morning and then he sat down and determinedly worked his way through it, and the proof was complete. Now, what did Arrow really say? He said the following: if the only kinds of welfare functions which are allowable are those which are based on individual utility orderings, where the utility functions themselves are ordinal and interpersonally non-comparable, then we don't really have to take recourse to numerical representation. We don't have to have a utility function. We can just make do with orderings, or with the binary relations, which are rankings of pairs of alternatives. And a particular kind of binary relation is an ordering, which is a binary relationship which is reflexive, which is complete, and which is transitive. Okay. So he said that the essential datum which is employed for aggregating preferences is the n tuple of all possible individual preferences. Okay. So supposing there are n people in a society and each of them has a certain preference ordering on the set of alternatives x. All these R1, R2, Ri, Rn, where Ri is the preference ordering, weak preference ordering of the ith person in the society. So the problem which welfare economics addresses itself to when it talks about a social welfare function, which is essentially a procedure for aggregating individual utility functions into a welfare function for the society as a whole, can be translated within the Arrow framework into an exercise in specifying a social preference ordering, call it R, okay, which is some function of the set of individual preference orderings R1 to Rn, one ordering for each of them. So this is the problem which Arrow presented to himself as a way of summarizing the principal concern of welfare economics. Now obviously you can't proceed any further with such a bare-bones statement of the problem unless you proceed to invest this function f with some desirable properties. Okay, so what might be a set of desirable properties? And the properties which Arrow suggested, and I will invite you to tell me whether those properties are exceptionable or unexceptionable, okay, are the following. He thought about 4 properties. Incidentally, each of these binary relationships is an ordering, and the social relationship is also assumed to be an ordering. Namely, R is a binary relation between a pair of alternatives x and y, such that xRx, or all x, that means it's reflexive, xRy or yrx, one of these must hold, so it's complete, and xRy and yrz must imply xRz, namely it's transitive. So we're dealing with orderings also. Okay, now to restrict the function f, okay. Now one possible function that you can think of and which we're all very familiar with is the method of majority decision. Okay. Which simply says that if a majority of individuals should prefer some x to some y, then society should prefer x to y. Now consider a situation in which you have 3 individuals who have the following preference ranking. Now in choosing between x and y, if you use the majority rule, what do you find? Person 1 prefers x to y. Person 2 also prefers x to y. Okay. Although, I'm sorry, person 3 prefers x to y, although 2 prefers y to x. But a majority of people, 2 out of 3 prefer x to y. Okay, so with the majority rule, we must have x preferred to y. Right? Now consider the pair of alternatives y and z. 1 prefers y to z and so does 2. 2 also prefers y to z. And even though 3 prefers Z to Y, it doesn't matter, he's beaten out in the majority contest by 1 and 2. So we must have, in accordance with the preferences expressed by the majority, Y, P, Z. Now notice that as a requirement, as a necessity of logic, we need P to be transitive. So if X is preferred to Y socially, and Y is socially preferred to Z, then by transitivity this must imply that X must be preferred to Z. Okay? Now, what does the method of majority decision tell us? Person 1 prefers X to Z, but 2 prefers Z to X. And 3 also prefers Z to X. So a majority of people prefer Z to X. Find the method of majority decision, and you have a function. So you end up with a logical contradiction. This is what is known very commonly in the literature as the paradox of voting, which, much of the initial work on the paradox of voting was actually done by a magician and mathematician called Charles Dodson in the 19th century. Is anybody familiar with this name? Actually, I think all of you would really know who it is. If I tell you the name under which he actually achieved fame. This is Lewis Carroll, who wrote Alice in Wonderland. So he did a lot of initial preliminary work in social choice theory. And that's why you will find that Through the Looking Glass is a book which is profoundly full of logical paradoxes. And if you want to get a good flavor of some of the very many hidden meanings in Carroll's book, you should read the edited version of it done by Martin Gardner, who was himself a mathematician. So we know that the method of majority decision doesn't really work. If you allow people to have any logically possible configuration of preferences, there's nothing illogical about a set of preferences. And if you allow every logically possible set of preferences, then there might be some configuration of preferences for which you get these sorts of cycles. So in general, the method of majority decision does not work as an aggregating mechanism. Now, we can ask ourselves, okay, MMD, method of majority decision, doesn't work. Can we think of some other? Okay, this is a simple majority. Will a 2/3 majority help? Or should we rank alternatives by awarding points to each candidate, depending on how they fare in the ranking of each individual? That's called the border rank order weighting procedure, okay, which was suggested by a French mathematician called Borda as a procedure for electing people to the Academy of Sciences in France. So you can think of other mechanisms. So what you can do really is to list all the possible mechanisms that you can think of and see whether they meet up with the same fate as the method of majority decision, or whether some of them escape the net. But you see, potentially, the number of aggregation mechanisms that you have is infinite. Okay? So, undertaking this business of counting each possible aggregation mechanism that you can have and checking to see if it goes through in some satisfactory sense might not be a very sensible way of dealing with the problem. Which is why Arrow was led to suggesting that a more compact, a more economical way of dealing with this problem is to invest this aggregation mechanism F with certain properties. And then seeing what is the class of aggregation mechanisms which satisfy these properties. So the first property that he spoke of was what is called unrestricted domain, or condition U, which simply says that the domain of this function must allow every logically possible configuration of individual preferences. Okay, so what do I mean by that? Supposing you have just two individuals in society, call them 1 and 2, and you have three alternatives, X, Y, and Z, Okay. Now x can rank them like this. Okay. And for each ranking of x, or of ones in this fashion, 2 can rank it also x, y, z, or z, x, y, I'm sorry, or x, z, y, or y, z, x, or y, x, z, or z, x, y, or z, y, x. Now, I'm not talking about indifference relations, I'm only talking about strict preference relations. So, supposing this is one's preference ordering, okay, 2 can rank the 3 alternatives in any one of 6 different ways. Supposing that x, z, y is 2's preference ordering, then again 2 can rank these 3 alternatives in 6 different ways. So for each of 6 ways in which 1 can order these alternatives, there are 6 ways in which 2 can order this set of alternatives. So altogether there will be 36 preference orderings. Okay? Only, even if you discount indifference relations, strict preference orderings, there will be 36 with just 2 individuals and 3 alternatives. Now, none of these preference orderings is logically controversial. It's not as if somebody is preferring x to y and y to z and z to x again. So there are no transitivities of any kind. So as long as individual orderings are logical, what I have said is you must not arbitrarily curtail the domain of the aggregation mechanism by saying certain kinds of preferences are impermissible. So every logically permissible configuration of individual preferences, which if you confine yourself to strict preferences in the case of 2 individuals and 3 alternatives, would add up to 36 different possible configurations. Every one of them must be allowed. That's why this condition is called universal domain or unrestricted domain. You must not seek to restrict the domain in any fashion. And if you like to think of it that way, it's also the assertion of a certain kind of liberalism. You can't tell people you may have this kind of preference, but you may not have that kind of preference. Because the whole object of aggregating individual preferences loses much of its flavor if you're going to start censoring preferences. So that is the motivation underlying the first condition, which is unrestricted domain. The second one is what is called the independence of irrelevant alternatives. Now, actually, this is a somewhat technical condition, but it should, on the face of it, make sense to you. It was first invoked by von Neumann and Morgenstern when they were dealing with the theory of games, and they employed it in the context of the assessment of calculations based on expected utility. There they were dealing with prospects, here we are dealing with certain states. And essentially what the independence of irrelevant alternatives demands, as the name suggests, is that the social preference over any pair of social states x and y must depend only on individual preferences over that pair x and y. So if I am seeking to rank socially or collectively a pair of alternatives x and y, then the preference aggregation mechanism must rank x vis-a-vis y only on the basis of information which is supplied on individual rankings of x over y, not individual rankings of x over z, or y over z, or z over w. In other words, the social ranking of any pair of alternatives must be independent of individual rankings over irrelevant alternatives. Okay? So if the relevant pair of alternatives is x and y, then social preference must ultimately depend only on individual preferences over x and y. Now it can be demonstrated, although I'm not going to do it, that if the independence of relevant alternatives condition is violated, then as a corollary, you run every chance of violating a certain simple consistency condition called contraction consistency. What does contraction consistency say? it says the following. Supposing you have some set n of alternatives, okay, and you choose, through a process of selection, you choose some set of alternatives from n, and let's call that the choice set of n. C of n is simply the set of alternatives which, through some choice procedure, are selected from n. Okay. Now, supposing there is some particular alternative x which belongs to the choice set of n. Okay. Now, consider a subset of m, let's call it n prime, such that x also belongs to n prime. Okay. Now, if n prime is a proper subset of n, and x was considered a best element in n, and if x is also a member of n prime, then x must continue to be selected from n prime. So x must be a function of the choice set also of n prime. So in other words, when you contract the set from which choice has been effected, a winning candidate in the original set must continue to remain a winning candidate. So if you are a badminton champion of your state, then presumably you must be a badminton champion in the university. Okay. So in any smaller set which subsumes all these, which is subsumed by the larger set, if you were originally selected, then you must continue to be selected. Now it can be shown that if the property of the independence of relevant alternatives is violated, then there's a good chance of violating this condition of transaction consistency. So that seems to be, on the face of it at least, a perfectly innocuous demand. That, you mustn't violate transaction consistency. Okay? And hence the possible importance of condition I, which is the condition of the independence of irrelevant alternatives. The third condition is a condition of unanimity, with which we are becoming increasingly familiar. It's simply called the Pareto Principle. Okay? Which says that given any pair of alternatives x and y, if everybody prefers x to y, then collectively x should be preferred to y. So you don't go against unanimous results. Okay? So that's what the Pareto Principle says. Which again seems to be a way of ensuring that, that the common will does not go against an identical individual will. Everybody thinks the same way, then why go against it? That's the Pareto principle. And the fourth principle is what is called the non-dictatorship principle, condition D, which simply says that it's a bad aggregating mechanism which will decide that there is some one individual such that his preferences over any pair of alternatives must always prevail as a social preference, irrespective of what other people feel. In other words, you're ruling out the possibility of dictators emerging in this exercise of preference aggregation. We're saying there should not exist any person who is a dictator. And by a dictator is meant an individual whose preference over any pair of alternatives will always prevail, irrespective of what the preferences of other individuals might be over that same pair of alternatives. So this was then the question which Arrow himself addressed himself to, which is supposing you have a social preference aggregation mechanism R, which is an ordering, which is defined on a set of individual orderings. And if you restrict the aggregation mechanism F, the Arrowian social welfare function as it was called, if you restrict it by the requirements, that function's domain must be unrestricted, i.e. allow every logically possible n-tuple of individual preferences. B, that it should satisfy the condition of independence of irrelevant alternatives, namely that the social preference over any pair of alternatives must not depend on anything other than individual preferences over that particular pair. Third, that it must respect the Pareto principle, namely a simple principle of unanimity. And fourthly, that it should not allow dictatorships. The question arises, what is the class of functions f which satisfy these four conditions? And Arrow's answer was this. It's the empty set. There exists no preference mechanism which satisfies all four of these conditions. So effectively what Arrow did was he slammed the door shut on a certain line of inquiry in the most brutal way you can imagine. Forget it. I mean, it's just logically inescapable. You can't do a damn thing about it. It simply does not exist. It's not just the method of majority decision, which we know from the simple exercise in the paradox of voting to be problematic. Think of any aggregation mechanism which satisfies the first three conditions. If it satisfies the first three conditions, then it must result in the emergence of a dictator. So I'm not going to go into the proof of this, but I would advise you very much to take a look at Amartya Sen's paper of 1979 in Economic Journal. It's called Personal Utilities and Public Judgments, or What is Wrong with Welfare Economics, in which he gives, I think till date I have not read a better exposition of Arrow's theorem in terms of its interpretation. And what he shows is that because you are dealing only with individual orderings, first of all, you've ruled out all non-utility information. And even the utility information which you are employing is so impoverished. You don't allow for cardinality, you don't allow for interpersonal comparability, you will insist on restricting yourself to ordinal, interpersonally non-comparable utility functions, which at best are increasing and therefore fulfill the Pareto principle. If you do that, then you're going to void the set of possible preference mechanisms which are available to you one by one until you're left only with the dictatorial preference aggregation. So this was the basic message which emerged from the development, if you can call it that, of what was then called the new welfare economics. Now, what implications might this have for certain kinds of distributional questions, or in particular for conflict situations? Because the kinds of situations that we're always facing are certainly not ones in which everybody is thinking the same way. You know, the Pareto principle tells you how to react to a situation in which everybody is agreed on the ranking of a pair of alternatives. But that is not the rule, that is the exception. The rule is one in which if you have 5 people, and if these people are economists, you'll have 6 views on how they go about it. So if you have conflicting opinions, if there is conflict, how will that be resolved by an aggregation mechanism? What Sen did was to come up with a theorem which is very similar in spirit to Arrow's theorem. It comes from the same basic stable. He also was looking for a preference aggregation mechanism which satisfies condition U, which satisfies condition I, which satisfies non-dictatorship, and which satisfies a slightly strengthened version of the Pareto principle, let's call it PP prime, PP, which is a strong Pareto principle. Okay? PP is a weak Pareto principle.